Radar Systems Group of El Segundo, California provides the radars for the nation's frontline fighter aircraft. This program will offer a brief look at our highly complex system of radar production. The primary business of Radar Systems Group is to produce radars of superior performance, quality, and reliability. High-quality products reflect the group's commitment to total quality control in every area of product operations while maintaining cost-effective production. These products are densely packaged electronic systems and incorporate many small components. Therefore, close attention to detail, quality, and precision is essential in every phase of the production operation. A time and cost savings practice pioneered by Radar Systems Group is its use of producibility laboratories. These laboratories make up a microcosm of the total product operations division. Designs are fabricated, studied, and tested under actual production conditions to optimize them for efficient, cost-effective manufacturing. The hybrid microelectronic producibility laboratories equipment and facilities duplicate hybrid production and test operations. Because hybrids are small, lightweight, and operate extremely fast, they are vital in helping reduce the size and weight of airborne radars, as well as increasing their overall capabilities. The Advanced Technology Development Laboratory develops and implements advanced production methods, automated assembly, and robotics. It helps ensure that technical innovation makes the transition from design to an integral and reliable part of production. The benefits from acquiring and implementing data from the group's producibility laboratories include lead time reductions, production economies in rework and field service savings, improved quality, higher yield of products, and more efficient production. Production operations are a highly complex system of operations. Each requires a high degree of precision. These operations include receiving, fabrication, hardware assembly, and systems test. Incoming components and raw materials are extensively tested and inspected to ensure conformance with contractual requirements. Eliminating marginal quality materials and components before they reach production results in considerable savings and helps reduce handling and rework. It also provides our suppliers with feedback to use in identifying and correcting problems in their operations. The group's main incoming parts inspection area processes nearly 10 million individual items annually, everything from nuts and bolts to complex electrical circuits. Documentation accompanying these products is checked to ensure correct identification is maintained throughout production. Once these components and materials meet the group's high standards for quality, they are incorporated into the various fabrication and hardware assembly processes. In fabrication, our production facilities are continually being improved and upgraded. For example, high-speed machining is needed to produce intricate, thin-walled parts. Recently, a standard, numerically controlled machine was modified to a spindle speed of 100,000 RPM, a speed roughly 25 times faster than any conventional machine. Because of its success, 5 more machines, each with high-speed capabilities, have been added to production. Fabrication begins in the printed wiring board manufacturing area. PWBs are the building blocks of the group's radar systems. They provide the primary means for interconnecting electronic components. A PWB may consist of as many as 14 layers of copper panels, each separated by a thin layer of insulation. The layers are bonded together by an epoxy material. Fabrication of the PWB begins with photoprojection of the engineering design onto each sensitized copper panel, etching it, prepping each layer, and laminating it. Laminated PWBs are then placed on a computer-controlled drilling machine where a CAD/CAM link directs the drilling of interconnect holes as directed by the design database. Each machine can drill up to 4 identical stacks of boards simultaneously. After drilling, the multiple layers in the boards are connected through a plating process. Automatic timing, temperature control, and solution monitoring guarantee that all operations are precisely controlled. After plating, additional operations include sending the copper panels through a flexible automatic circuit tester, commonly referred to as HAC testing, which performs a high voltage and continuity check, solder fusing, routing, and the bonding of 2 PWBs onto a metal heat sink. Finally, a crossover and a connector are fitted to electrically tie the 2 PWBs together into a module assembly. Before electronic components are mounted on the module assembly, they go through a series of preparatory operations in which components leads are automatically formed, trimmed, and tinned. This machine removes the components from carriers, cuts and forms the leads, and places them on tinning bars for the tinning operation, where an exact amount of solder is tinned on the leads. The axial loader loads the formed and tinned components back into carriers and into magazines for automated assembly. The axial lead component assembly system selects a specific part from one of 50 magazines and verifies it. If the part or its position in the carrier is incorrect, it will be detected and immediately ejected while still in the carrier. The part is now available for examination and analysis to determine the cause of failure. If verified, the system removes it from the carrier, places it in proper position on the board, and reflows solder on the leads and board. The process produces considerably higher levels of quality output than manual assembly, and in a fraction of the time. Flat pack components are assembled in a similar manner on the HPS 300. An average board is completed in 1 hour compared with 8 hours it used to take a skilled assembler to do the same job. Radar Systems Group is continually improving and upgrading its production facilities. For example, 2 modular component assembly systems automatically select parts from one of 32 magazines, verify and align them, and reflow solders them on the printed wiring board. Each automatic assembly system utilizes a robotic arm for consistency and high quality. Other production upgrades include the automatic installation of leadless chip carriers and vapor phase soldering for the manufacture of the APG-70 radar. Automation contributes significantly to increased productivity and the group's recognized product reliability, whether the automation occurs in assembly, in component prep, in PWB manufacturing, or in machining operations. Another factor contributing to Radar System Group's product quality is its commitment to extensive testing and inspection at every level of assembly, from incoming raw materials to every layer of a printed wiring board, as well as the completed PWB assembly, module, unit, and the system itself. Environmental chambers test systems under simulated field conditions. These tests are vital in the production of reliable radars, such as the APG-65 for the FA-18. This radar has demonstrated its reliability in operation, averaging the equivalent of more than 2 months of flight time without a squawk. In addition to testing, Radar Systems Group continues to improve and upgrade its production capabilities and capacity by maintaining its commitment to improve productivity. Radar Systems Group is dedicated to delivering products of superior performance, quality, and reliability on time and at an affordable cost.